So I'm Mark Lachinsky. I'm a senior cloud architect at Timehop, and today I'm going to be talking about how AWS enabled able to spin off a new line of business. This is the outline I'm going to be going over today. Just a little bit of background, what we do, who we are. Now I'm going to talk about the spin-off activities and all that went into that effort, and a little bit of conclusions, takeaways that you can take away as best practices or things we found out that you may leverage for your own purposes later, and then I'll leave it open for Q&A after that. So this is Timehop. So Timehop basically helps you reconnect with your memories. The way this works is that you can download the app from Google Play Store or App Store, and once you open it up, you connect your various social media accounts for Facebook, Twitter, Instagram, etc. Right, and so basically the next, we do a bunch of work in the background. Next day when you check it, we present you your memories from years past on a daily basis. So basically anniversary photos. And you'll see little, our wonderful Abe, the mascot, who I'm also sporting the t-shirt. He's got a brother, and his name is Nimbus. So Nimbus is a true header bidding ad exchange focused and optimized for mobile via S2S. So what does this really mean? So Timehop as a publisher, as a mobile app, we basically provide an application free to all of your users. But we also still need to be able to pay our AWS bill somehow, right? So the way we do this is through ads. And now, being able to incorporate ads into your mobile application is quite a bit of an effort in and of itself. But that's not usually good enough, right? You don't want to just get any ad. You want to be able to get the highest value ad, and you do this through an auction, right? Now, you don't want to run an auction on your mobile application, so you offload that work to a back-end server in this example, right? And so basically, your mobile application is just going to be responsible for requesting an ad, and then having the backend, having Nimbus do all of its magic, getting the highest value ad, and sending that ad back to your application. Timehop in this example, and the application's responsible for rendering that ad, and then you can be able to get the highest value monetization from within your application. So that's roughly Nimbus in a nutshell. And this is basically the business that we spun off, and we're going to be we're making it available to every other publisher. We realized pretty quickly that we're not the only mobile application out there, and this would be really useful for a lot of other people too. So a little bit of background on sort of just infrastructure and team to make both these lines of business reality. But we run basically over 100 instances to support both these applications. We utilize over 20 AWS services to be able to create about 15 back-end microservices, and we do this all with about 4 back-end engineers. So this is pretty impressive, and it really attests to the power of AWS and what you can really do with it. Let's see if this clicker works. There we go. So jumping into the actual spinning off the business, right? So once the business decision was made to actually create a new line of business, that those kind of marching orders came down to the technical team, and we needed to decide what is it that we need to do to make this happen. And one of the first things was, well, do we keep Nimbus in the same Timehop account and just create a new VPC, or do we create a whole new account? We went with the whole new account route for multiple reasons, particularly just ease of keeping track of finances, and just your infrastructure. So you don't have when you look at your dashboard on EC2, you don't see Nimbus cluttered along with a bunch of other stuff that we use to do Timehop. So it just makes a logical sense to keep those separate accounts. Now, the steps we took was, all we had to do is create a brand new AWS account, which is the AWS Billing Master account. And we utilized AWS Organizations. If any of you have actually created a new account, you know there's quite a few steps that you need to take to get this done. You need to put in your credit card information, billing information, contact info, etc. But with AWS Organizations, once you have that master billing account set up, it's really easy to create additional sub-accounts on that. So it's very easy to create sub-accounts from that, right? So with a couple of clicks, we will quickly create our Nimbus account and link our existing Timehop account and gain all the benefits of consolidated billing. You know, obviously this is not the most complex scenario in the world, just a one new account, but for all of you and whatever organizations you are, and AWS Organizations is really great for creating accounts for however you organize your accounts. So once we created the account and we did some initial VPC setup to be able to start pulling the Nimbus artifacts over. Now, this was a relatively easy process. We needed to make sure, though, that we weren't just like cutting Nimbus off and then turning it back on in this new account. We needed to be able to pull the resources over without any interruption to our existing infrastructure and applications. So the way we did this was just we created a temporary VPC connection between the two VPCs and then started slowly pulling stuff over. And this was actually really easy utilizing Beanstalk. That's the way we deploy our applications. So basically we performed some minor EB extensions, tweaks, not tweets, and we just deployed the new applications into the new account and VPC. And then once we got that over and made sure everything was still talking to back in the Timehop account, we started slowly rolling out all the other supporting infrastructure and microservices into the new account. For example, we had Elasticache and Elasticsearch. And Elasticsearch is kind of a big one I want to touch on because this was quite a bit of a learning experience. Before coming to Timehop, I had never really dealt with Elasticsearch, and I got quite a bit of experience with it. So basically what happened is within our Timehop infrastructure, we had been using Elasticsearch and it had been configured long before I had even gotten there. And we used the architecture where we wrote out to Firehose, and Firehose sent all the data into our Elasticsearch cluster. And it was all configured with default values. So we were basically configuring a Firehose with daily rotations of indexes in there. And so we were rotating on a daily index. But soon after we migrated into the new account, our Elasticsearch cluster actually kind of fell over because we had too many indexes in there, too many shards, and basically just performance wasn't there. And after writing to it, it just fell over, and we just had an outage. Now, we didn't lose any data, thankfully, because within Firehose, we had the option of being able to write the data both to Elasticsearch and S3. So even though our Elasticsearch cluster went down, we were still writing all of our ad impression data into S3. So while we quickly were doing some firefighting, brought the cluster back up pretty much just by making the cluster much larger. I think we just doubled the size of the instances, and that was enough to sort of let us hobble over for a little while. But obviously we needed to be smarter about this. We didn't want this outage occurring again. So I started out onto a small little venture of doing as much research as I could as to learn about the innards of Elasticsearch. So obviously I did my own research, but I also reached out to AWS support, and I talked to multiple people on the phone and just tried to get their input and expertise on this technology that I'd never really dealt with too much. I also utilized our AWS account manager, Sam, who's here in the crowd. Thank you, Sam, again. But he helped us get FaceTime with Elasticsearch gurus, right? So a lot of the stuff that I was learning and hearing from them, I was able to validate and really try to really able to learn what next steps I needed to take. And really what I learned was earlier I mentioned we were doing index rotation on a daily basis, which isn't great. There's a best practice within Elasticsearch to do to target shards of 50 gigabytes. What that means, so to give you a little bit of more context, Within Elasticsearch cluster, you have indices. An Elasticsearch cluster itself is made up of multiple nodes or instances. And index itself is also made up of shards. And each, we try to keep another best practice is to keep sort of a one-to-one ratio between shards and indexes. So you basically have an index at the cluster level and shards at each individual node levels. And you want to target those shards to be 50 gigabytes, like I just mentioned. But with rotating on a daily basis, you can't target really a specific shard size, right? Because one day you could have 5 gigs of data in there. The next day you could have 100 gigs of data. Just whatever amount of data you happen to have that day. And maybe for more stable environments, what I mean by stable is sort of like steady state run operations where you know that every day you're throwing 50 gigs of data there, that's fine. But for our environment as a growing company, bringing on new clients with this new business, that doesn't work very well because every day our clients are sending more data. We are getting new clients on the Timehop platform who are sending, all generating more data, right? So we can't expect that on a daily basis. We can predict on a daily basis how much data we're going to get. So with the help of AWS support, in order to be able to target this 50 gigabyte shard size, we learned about this rollover API that we could implement. There's no index management tools internally of Elasticsearch itself, so we basically had to create our own mechanisms to work around it. And what we did was utilize AWS Lambda right there, right? So the first Lambda function we created was basically, like I said, utilizing the rollover API, and we were able to specify, say, hey, I want my index to be, 150 gigs, which translates to 50 gigabytes per shard because we have 3 nodes, for example, right? So that solved our performance problem. Since then, a lot of our metrics, performance metrics have been really smooth. Business has noticed a significant increase in speed of their dashboards when they log into Kibana to look at their reporting on a daily basis. We had a second problem too, though. Elasticsearch isn't exactly the cheapest service in AWS, and we want to, as a small company, we still want to keep our costs down. So we worked with the business trying to figure out how much data retention we really wanted to hold, right? And it doesn't make sense to hold 10 years of data if you don't need to report on 10 years of data. So speaking with the business, they decided that a quarter's worth of data was good. So that that helped drive us, helped us drive when we could get rid of some of this old data, which also helped with performance because the more indexes and shards you have in your Elasticsearch cluster, the less performant it is, and just more overhead there is, right? So that's why I created another Lambda function, and basically this one scanned through all of our indexes, looked for anything over a couple of months, and if it was over a couple of months worth of, if it had data in it that was over a couple of months, just delete that index because we know we don't need it. And if the business ever did come back to us and say, hey, we want to run some old or historical data, like I said earlier, we're dumping all this data into S3, and we're able to just run Athena queries, utilize Athena to run queries against that older historical data. So that's quite a bit of a learning experience with Elasticsearch there. So next up is global expansion. So Timehop itself, we started out with just the North Virginia US East 1 region because most of our user base, not all, but the majority of it is in North America, and this served our purpose as well. But as I mentioned, we've got, as Nimbus is a service for other mobile applications to be able to get better ads on their platforms. They are not Timehop. They may very well have clients all over the world, and many of them very much do. So we need to be able to expand our footprint globally, and we are able to do this in a matter of days with AWS by being able to create our VPCs out there, do all of our VPC connection, VPC peering, and become a global company, all with 4 back-end engineers in a matter of a couple of days. So some just key takeaways, just to review what I kind of talked about. Being on the AWS platform enabled the business to grow and onboard clients really quickly. AWS support accelerated filling any knowledge gaps that we had, so they're very instrumental. Utilize them as much as you can. And then, they're not going to solve your problem for you. I think that's still, our jobs to do, but they will definitely point you in the right direction. And then finally, talking about default configurations within AWS, as a small company, you kind of want to you do need to get things out there and move on to the next higher priority thing. So using defaults initially is fine. There's no need to pre-optimize anything. You just start optimizing and diving deeper once things break, and then you just go in and fix it quickly. So with that, that's pretty much the end of my presentation. If you can, always check us out at timehop.com, or if you're interested in the Nimbus, it's adsbynimbus.com. Thank you.